Hello students, we will learn about kingpin inclination in this video. It is better known as steering axis inclination SAI. Steering axis inclination is the angle between the steering axis passing through the kingpin and the vertical axis of the tire normal to the road. Steering axis inclination is measured from the front of the vehicle. The angle SAE is non-adjustable. It can only change if the steering knuckle is bent. When steering is applied to turn the vehicle, the tire axis will follow the path, keeping the steering axis as the center. Because of that, the tire will face the downward force, and because of that, the road surface will provide the lifting force on the tire. As road is the rigid construction, and we cannot force the road in the downward direction. Because of that, tire will try to lift itself, and because of that, when we release the steering, the tires will come back to its original position after the turning effect. In this figure we can see the steering axis and the vehicles we use nowadays. In the left side we have used the Wishbone suspension system, and in the right side we have used the McPherson suspension system. We can see the steering axis is inclined into the inward side, and this is known as steering axis inclination in the inward side. The angle value varies from the 3 degrees to the 8 degrees. Steering axis inclination also assists during the steering. The more the angle, the steering will be harder, so that the value of the steering axis inclination is kept within the limit. Now the steering axis inclination and the camber angle. Sum of this is known as the camber angle. And in this figure we can see the scrub radius. Now what is the definition of the scrub radius? Scrub radius is the distance between the contact point of the vertical line and the contact point of the steering light with the road surface. We can see in this figure the enlarged view has been shown of the scrub radius. Scrub radius value can be 0, positive and negative. In the first figure the scrub radius is positive. It is known as positive when both the lines will intersect below the road surface. If it intersects on the road surface, the scrub radius will be 0. And if the lines intersects above the road surface, the scrub radius will be negative. Generally, the scrub radius is provided positive because positive scrub radius will tend the tires to toe out during the turning, which will assist the positive camber during the turning, which will provide the stability to the vehicle, and it won't allow the vehicle to roll over. Hello students, in this video we will understand the phenomena of toe in and toe out in a vehicle. Toe in is the amount by which front wheels are set closer together at front compared to the rear when vehicle is in stationary motion. Toe out is exactly opposite of this manner. In this figure, we can see that front wheels are tilted inward from the front side. That phenomena is known as toe in. In this second figure, we can see that two tires are tilted outward from the front side, and this phenomena is known as toe out. Toe in and toe out are measured in the distance or in millimeters. The distance at front and the distance at rear are measured, and the difference between them is known as either toe in or toe out. Toe out is generally given in the front wheel drive cars and the front side. During the driving, axle pulls the vehicle, resulting forward movement of the suspension arms. So to compensate for the negative effect, toe out is provided. Toe out will also help in the camber during the cornering and will provide the cornering stability. If toe out is not provided, then when vehicle is running, the tires will tilt itself in inward side, and because of that, while vehicle is running, the tires will be in the toe in motion. To avoid that motion, the toe out is provided from the start. In case of the vehicles which have rear wheel drive, they use the toe in method to compensate for the toe out of the vehicles during the driving. In this case, the suspension arms will push the wheels in the outward direction. Because of that, when vehicle is driving, the tires will be positioned in the straight manner and vehicle will drive in the straight motion. The next geometry of the steering is known as the slip angle and the cornering force. The slip angle will be affected while vehicle is taking a turn. When vehicle takes the turn, the centrifugal force acts on the vehicle, which will produce the side thrust. To maintain the vehicle's position while turning, the tires of the vehicle will incline itself in the outward direction. So it will make the positive camber. That positive camber during the turning will known as the slip angle. The slip angle will produce the cornering force in the opposite direction of the centrifugal force. The cornering force can also be called as the centripetal force, which is always opposite to the centrifugal force. In this figure, we can see that side thrust and cornering force are both parallel to each other but are acting in the opposite direction. There is also some distance between them, which is known as the pneumatic trail. Because of the two forces acting opposite to each other and in the parallel direction, a couple will be generated. Because of that couple, the tires will face the torque. This torque will help the vehicle in the self-stabilizing, which means when we turn the vehicle, after turning, when we release the steering wheel, the tires of the vehicle will come back to its straight position automatically because of this torque generated because of these two forces, side thrust and cornering force. This torque is known as the self-rightening torque. In this video, we will understand the phenomena of understeer and oversteer. Understeer and oversteer both are very important for the steering system of the vehicle. When the slip angle of the front wheels are greater than those for the rear wheels, the radius of the turn is increased. This means that the vehicle will turn less sharply than it should be for the given steering wheel effort. That phenomena is known as the understeer. In the first figure, we have shown the understeering effect. There is two paths of the vehicle. One is the green path and second is the red path. The green path is the ideal path. Ideal path, which means that the vehicle should have followed this path for the given steering effort. But because of the understeering effort, the vehicle followed the red path and the turning radius will be increased and vehicle will not steer as much as it should have for the given effort. In the second figure, we have shown the oversteer, in that when the slip angle of the front wheels are less than of the rear wheels, the turning radius will be reduced and this phenomena will be known as the oversteer. In this path, we can see that the green path is the ideal path and the red path is the oversteering path. In this, we can see the vehicle turns more sharply than it should have for the steering given effort. In this both phenomena, understeer can be controlled easily, but to control the oversteer is more difficult, as during any one of these phenomena, the first response of the driver will be to correct the steering by giving the more effort to the steering wheel. In the case of understeer, it will help and vehicle will make the turn with lower turning radius. But in case of the oversteer, when we try to correct the steering by giving the more effort to the steering wheel, the oversteering effect will be increased and there are chances that our vehicle can struck the object and accident can happen. Oversteering can be controlled by moving the steering wheel in the opposite direction. Understeer is generally faced in the vehicles which have front wheel drive and oversteer is generally faced in the vehicles which have rear wheel drive. Understeer generally can be controlled easily and it is not as dangerous as oversteer. Oversteering is helpful in the racing cars. Racing car drivers are skilled to use the oversteering for their advantage. There are some simulation courses which teach the racing drivers to use the oversteering as the drifting and the racing vehicles. Drifting is useful to take the sharp turns in the racing tracks. Now we can also understand in the understeer and oversteer with another way. For example, when the rear wheel drive vehicle is going at a high speed and vehicle is turned, the front wheels will respond to the steering effort. But due to the high speeds, the rear wheel will not follow the path of the front wheel and it won't turn. Because of that, the vehicle will skid from the rear part, and because of that the steering radius, or we can say the turning radius of the vehicle, will be decreased and vehicle will take the sharp turn. By controlling this skidding effect, we can use it as the drifting method. In the case of the front wheel drive vehicle, when the vehicle is going at a high speed and we try to turn the vehicle, the front wheels will not give the response to the steering effort. And because of that, the vehicle will take the another path and the turning radius will be increased. That is known as the understeering effect, and which is faced in the vehicles we use in general basis. So in this image, we can see understeer and oversteer. In the left figure, understeer has been shown, and in the right figure, oversteer has been shown. In the left figure, the car is shown as a front engine front wheel drive. In that, first or front wheels are shown with the blue color, which shows that when we are applying the steering effort on the front wheels, due to the high speed in the front wheels, the vehicle will not steer as much as it should due to the steering wheel effort, and turning radius will be increased. As we can see in the figure, in the left side, we can see while we are trying to steer the wheels in the right direction, but vehicle will try to go in the straight direction because of the higher speed and higher inertia, and it will not turn as per the steering effort. In the right figure, oversteer has been shown. In the case of the oversteering, the right turn has been shown. In that, rear wheels are been highlighted with the blue color. In this figure, in the right side figure, we have shown the rear wheel drive car. In that car, when we are trying to turn the car, the front tires will try to turn, but rear wheels will not turn due to the high speed, because rear wheel are just following the front wheels as steering is only given in the front wheels. Because of that, vehicle will skid from the back part or from the rear part, and vehicle will turn more sharply than it should, which is known as the oversteering. As already told earlier, understeering is more safer than the oversteering, because to control the understeer, it is easier to move the steering wheel in the same direction as the turning. But to control the steering in the oversteer, we have to move the steering wheel into the opposite direction, which is shown in this right side figure. In this image, understeering has been shown. As we can see, while we are trying to turn the vehicle, the tires make an inclined angle, but due to the higher inertia, vehicle doesn't turn according to the required turn, and it makes the higher turning radius. In this video, we can see the oversteering. The already explained phenomena happen here, in which when we are trying to turn the vehicle which have rear wheel drive, the front wheels will make a turn in the left direction, but due to the high speed, the rear wheel will not make a turn and it will skid with the tire. Because of that, the car will make a sharp turn and will create a minimum turning radius, and it can make a collision. Okay. If we somehow manage this oversteering effect by controlling it, we can create the oversteering effect into drifting. Drifting is actually useful in the racing cars while taking the sharp turns. We have to be very skilled to control this oversteering effect and convert it into drifting. For the drifting, actual simulation courses have been used by the drivers and they can do the oversteering and convert it into the drifting for their advantage during the racing.